Welcome to another JPJ Discovery video. The Big Bang should have created equal amounts of matter and antimatter in the early universe. But today, everything we see from the smallest life forms on Earth to the largest stellar objects is made almost entirely of matter. Comparatively, there is not much antimatter to be found. Something must have happened to tip the balance. One of the greatest challenges in physics is to figure out what happened to the antimatter, or why we see an asymmetry between matter and antimatter. This complex question is our topic for today's video. Antimatter particles share the same mass as their matter counterparts, but qualities such as electric charge are opposite. The positively charged positron, for example, is the antiparticle to the negatively charged electron. Matter and antimatter particles are always produced as a pair, and if they come in contact, annihilate one another, leaving behind pure energy. During the first fractions of a second of the Big Bang, the hot and dense universe was buzzing with particle-antiparticle pairs popping in and out of existence. If matter and antimatter are created and destroyed together, it seems the universe should contain nothing but leftover energy. Nevertheless, a tiny portion of matter, about 1 particle per billion, managed to survive. This is what we see today. In the past few decades, particle physics experiments have shown that the laws of nature do not apply equally to matter and antimatter. Physicists are keen to discover the reasons why. Researchers have observed spontaneous transformations between particles and their antiparticles, occurring millions of times per second before they decay. Some unknown entity intervening in this process in the early universe could have caused these oscillating particles to decay as matter more often than they decayed as antimatter. Consider a coin spinning on a table. It can land on its heads or its tails, but it cannot be defined as heads or tails until it stops spinning and falls to one side. A coin has a 50-50 chance of landing on its head or its tail. So if enough coins are spun in exactly the same way, half should land on heads and the other half on tails. However, if a special kind of marble rolled across a table of spinning coins and caused every coin it hit to land on its head, it would disrupt the whole system. There would be more heads than tails. In the same way, some unknown mechanism could have interfered with the oscillating particles to cause a slight majority of them to decay as matter. Physicists may find hints as to what this process might be by studying the subtle differences in the behavior of matter and antimatter particles created in high-energy proton collisions at the Large Hadron Collider. Apparently at the birth of the universe there must have been a 1 part in a billion asymmetry, favoring the production of normal matter over antimatter. Indeed, a tiny difference in behavior was discovered in 2011, but it's way too small to explain why the universe contains as much matter as it does. Might it be possible that half of the galaxies in the universe really consist of anti-atoms, anti-molecules, and anti-stars? Could the cosmos contain isolated pockets of antimatter? Almost certainly not. There's enough intergalactic matter connecting individual galaxies and clusters to set off annihilation, yet we don't see the gamma rays that would result if this were happening. As a possible alternative solution, Neil Turok of the Perimeter Institute for Theoretical Physics in Canada has suggested that the Big Bang not only produced our known universe, but also a mirror universe consisting of antimatter and evolving backwards in time. That would restore the symmetry, but it's a very speculative idea, to say the least, and all but impossible to either prove or disprove. Future research on the properties of antiparticles, as well as better statistics from space-based detectors like AMS-02, may eventually solve the antimatter riddle. There was nothing in Dirac's equation or in the known laws of physics to explain why the universe should prefer matter to antimatter, so where was it all? One suggestion was that the Earth just happened to lie in a relatively antimatter-free region of the universe. Perhaps there were whole stars made out of the stuff lurking out there. If so, it would be easy enough to tell, for as soon as antimatter comes into contact with ordinary matter, it is totally destroyed in a huge burst of radiation. And clearly, there are lots of questions needs to be researched to give clear answers. Thanks for watching. Don't forget to subscribe and watch another videos at JPJ Discovery channel. Feel free to comment videos and share the knowledge with everyone. Stay tuned for next video.